Hello everyone and welcome back to another video. In this video we're going to be explaining the Pythagorean theorem. So let's get started. So the Pythagoras or Pythagorean theorem basically explains that if I have a right angle triangle such as over here, and I know it's a right angle triangle if I see this angle over here, which is called a right angle, and it's represented by this half square and it's equal to 90 degrees. So the Pythagoras theorem explains that if I have sides A and B and C, the Pythagoras theorem explains how A squared plus B squared gives me C squared. So the number of A over here squared and the number of B over here squared, when you add them together, that's going to give me C squared. Now, a frequently asked common question is when I have the right angle triangle, so A squared plus B squared gives me C squared. How do I know where this C is going to be? Or how do I know where these A's and B's are going to be? So for the C is always going to be on this side of the triangle. This side is always going to be C. And this side, C, is called the hypotenuse of a triangle. So there are two ways of identifying a hypotenuse in a right angle triangle. So the first step is it will be the largest side. So if I have this right angle triangle over here on the top and I have 6, 5, and 8, I know that this A is my hypotenuse as it is the largest side. Now, what if we don't have the number of each side? So what if I just have the hypotenuse as C or as a letter? You can also identify the hypotenuse by seeing it opposite to the right angle. So I can see that this hypotenuse over here is opposite to the right angle. The right angle is way over here and the hypotenuse is way over here. So these are my two ways of identifying a hypotenuse, aka my C in the Pythagoras theorem. Now as for my A's and B's, the good news is it does not matter where it's placed. My A could be here and my B could be here, or it could be the other way around, where my B could be here and my A could be here. It does not matter because we are adding both A and B up to find C. So the placement of A's and B's don't matter, and all you have to know is that C is the hypotenuse and the two ways of identifying a hypotenuse. So back to the actual lesson. The Pythagoras theorem is A squared plus B squared is equal to C squared. So let me have an example of a question on the Pythagoras theorem. So here is an example question of the Pythagoras theorem. I have a right angle triangle and two given sides, 8 centimeters and 6 centimeters. And I have x centimeter over here, and it's telling me to find x. Now, we can tell that x centimeter, this side is the hypotenuse, as it is opposite to the right angle. So following the Pythagoras theorem, we'd write down A squared plus B squared is equal to C squared. And as explained before, these A's and B's, the order doesn't really matter, so I can say either 8 squared plus 6 squared or 6 squared plus 8 squared. So let's say 8 squared plus 6 squared gives me C squared. And now we turn the 8 squared and 6 squared into their actual respective numbers. 8 squared is 64, as 8 times 8 gives me 64. And 6 squared is 36, as 6 times 6 gives me 36. So 64 plus 36 gives me C squared. So 64 plus 36 gives me 100. So 100 is equal to C squared. Now, this is not my answer yet. 100 is the answer for C squared. We want C alone. So C alone would be root of 100, and that just gives me C. So root of 100 is equal to c, and c is x centimeter over here. So therefore, x is equal to root 100. So here is another example of the Pythagoras theorem. So I have a right angle triangle and I have two sides. This 5 centimeter over here and this 12 centimeter over here. Now in questions like these where you're going to need a little bit of thinking to identify the sides and the hypotenuse, the location of the right angle really matters. So I can see my right angle right here. So to identify the hypotenuse, I would need to find either the largest side or the side that is opposite to the right angle. Now obviously I can't find the largest side because I have a missing side x over here, so I can't really compare it. But I can see that this 12 centimeter is the hypotenuse, as we can see that this side over here is opposite to the right angle. So if I have the hypotenuse and I have 5, I just need to find this x. So how can I do this following the Pythagoras theorem, which is a squared plus b squared equals c squared? So we have c. C is equal to 12. And we have, let's say, a. A is equal to 5. So we need to find b. How can we find b? So we need to rearrange the formula so that b is what we're finding, aka x centimeters over here. So we'd have to rearrange the formula into b squared is equal to c squared minus a squared. Now, how does this work? For example, if I have 6 plus 4 is equal to 10. If I want to find 4, even though like we already know the number, all I have to do is 4 equals 10 minus 6, which is equal to 4. So it's basically the same way. We're just rearranging the formula. So we'd make x the subject, or x centimeters is what we're finding. So b squared is equal to c squared minus a squared. Now all we need to do is just put in the numbers. So b squared is equal to c squared, which is 12 squared, minus a squared, which is 5 squared. So b squared is equal to 144 minus 25. 144 minus 25 gives me b squared is equal to 144 minus 25 gives me 119. So my answer is just b equals root 119. So same thing here. If you're in a non-calculator exam, then you just write the root over here. And if you're in a calculator exam, you'd put root 119 into your calculator and you write the numbers, including the decimals. So b is equal to root 119, and b is basically x centimeters. Therefore, x is equal to root 119. And that's my final answer. So if you're someone who just prefers memorizing the equations, you can say that c squared is equal to a squared plus b squared. And then b squared is equal to c squared minus a squared. And a squared is equal to c squared minus b squared. If you're someone who just prefers memorizing instead of taking logic into account, then you can copy down this table. Okay, so now it's your turn. Have a go at these 3 questions. If you're going to answer them, pause the video from now, because I will answer them right now. So question number 1 is asking us to find x. We have a right angle triangle. We can identify it by this right angle over here. And I have 8 centimeters and 2 centimeters and x. So they want us to find x. Now, we can identify x as the hypotenuse, as it is opposite to the right angle. So therefore, I can just say a squared plus b squared equals c squared. Now, x is my hypotenuse, so it's going to be c squared. So all I have to do is chuck in 8 and 2. So 8 squared plus 2 squared gives me c squared. Now, we find the respective numbers for 8 squared and 2 squared. So I have 64 plus 2 squared, which is 4, gives me c squared. 64 plus 4 is 8, so 68 is c squared. And then to find c, it'll just be c is equal to root 68, which is equal to x. And that is my final answer. So question number 2, again, we have a right angle triangle, and it's telling us to find x. So I have 3 sides, 4 centimeters, 8 centimeters, and x. Now I can identify this 8 centimeters over here as the hypotenuse, as it is opposite the right angle, as we can see over here. So we have c squared, and we can just assume that 4 is, let's say, b. So we would have to write down a squared plus b squared equals c squared. Now we have c squared and we have b squared, so all we need to do is find a squared. So you can either just memorize it, or you can take it from logic, where a squared is just this number minus this number. So a squared is equal to c squared, which is 8 squared minus 4 squared. So a squared is equal to 64 minus 16, which is equal to 48. So a is just equal to root 48 and x, which is equal to x, and that is my final answer. Now question number 3 is a little bit tricky, where we actually have to prove that a triangle is a right angle triangle using Pythagoras. So question number 3, Adam says that triangle A is a right angle triangle. Is he correct? So I have a triangle of 3 sides, 4 centimeters, 5 centimeters, and 6 centimeters. Now, some people would just look at that and be like, no, because first of all, we don't have this right angle indication, and it just doesn't look like a right angle, because most of the time, right angles just look like this. Now, logically, they are somewhat correct, but it doesn't work like that. You need to actually prove it. So I have this triangle over here, and we want to use Pythagoras to prove it's a right angle triangle. How can I do it? So first of all, I'd have to write down a squared plus b squared is equal to c squared. Now, we stated that c squared is my hypotenuse, and we can identify an hypotenuse by making it the longest side. The hypotenuse is the longest side of the right angle triangle. Now here my longest side is 6. 6 is bigger than both 4 and 5. So c is actually 6, and I could just write it as 6 squared. And then a and b, the placement doesn't matter, so I just have 4 and 5 left, so I can just write 4 squared plus 5 squared. So now that we have these two sides, implemented into the equation, we can actually see, does 4 squared plus 5 squared give me 6 squared? So let's check. 4 squared is 16, and 5 squared is 25. And according to the Pythagoras theorem, it should give me 6 squared, which is 36. Now, is this correct? 16 plus 25, if we go ahead and add it. So 5 plus 6 is 11. Let me check the one here. 1 plus 2 plus 1 gives me 4. 41. So 16 plus 25 gives me 41. 41 is obviously not 6 squared, aka 36. So therefore, my answer is no. It is not a right angle triangle, as it doesn't go through the laws of the Pythagoras theorem. So not every time in the Pythagoras theorem do I just have a right angle triangle for me and then I have to find the sides. No, sometimes we can just have a word question and we have to construct our own triangle, such as this over here. So it states that a boat sails 5 kilometers due south and then 35 kilometers due east. How far is the boat from the starting position? So let's construct this. 5 kilometers due south. So if you don't know your directions, it's just like this. So this is north, this is south, this is west, and this is east. So a boat sails 5 kilometers due south. So I can draw a line over here, pointing downwards, and this is 5 kilometers. Then it goes 35 kilometers east. So I can draw an arrow over here, and I can say that this is 35 kilometers. How far is the boat from the starting position? So, first of all, the boat goes from this point A to this point B. Now it goes from this point B to this point C. It wants to know how far the boat is from the starting position. The starting position is A, and the boat is currently at C. So we can construct our own right angle triangle from this information and connect them. And this line over here is the distance between the starting position A and the last position, or where the boat currently is, at C. Now, all we need to do is use the Pythagoras theorem. We can assume that this is a right angle triangle, of course, and we can draw the right angle right here between the two directions. Pythagoras theorem, a squared plus b squared equals c squared. And then I have, and then a and b, the placement doesn't really matter. I can write 35 squared plus 5 squared, or 5 squared plus 35 squared. So 35 squared plus 5 squared gives me c squared. And now for questions like these, I can actually just pop up my calculator. So to find 35 times 35, and that gives me 1,225. So 1,225 plus 5 squared, which is 25, is equal to c squared. So 1,225 plus 25 gives me 1,250, and all of that is equal to c squared. So how far the boat is from the starting position is root 1250, and that is my final answer. Now, something else that can also happen in the Pythagoras theorem is, instead of just getting a good old right angle triangle and then all we have to do is just find the numbers from there, we can actually get an irregular shape or multiple shapes merged into one, and we have to find out the right angle or the sides on our own, such as this question over here. So I can get a question like this. As we can see, I have two right angle triangles, ABC, and another right angle triangle, ADC, on top of each other. So it wants me to find x centimeter over here. Using Pythagoras, we have the 4 over here. However, we need this side over here to find x, because we need two known sides to find a missing side or conduct Pythagoras. So we can see that the right angle triangle under it, I'll actually draw it like this. So I have D to A like this, which is 10 centimeters. And I have D to C like this, which is 2 centimeters, like this. And this is a right angle triangle, so I can just use Pythagoras to find AC, aka this side over here. So a squared plus b squared is equal to c squared. And then I have c squared, which is the hypotenuse, aka in this triangle here, as it's opposite the right angle. So 10 squared plus 2 squared gives me c squared. 100 plus 4 gives me c squared. So c is equal to root 100 plus 4, so root 104. So this side over here is root 104. And now is when I have two or more known sides on ABC, the right angle triangle. So I have A over here, and A to C gives me root 104. And then I have C to B, which gives me 4. And then I have over here C, and then I have over here x centimeters. So we know that x over here is the hypotenuse, as it's opposite the right angle. So a squared plus b squared is equal to c squared. So root 104 squared, or you can just really write it as 104. So 104 plus 4 squared, which is 16, is equal to c squared. So 104 plus 16 gives me 120, and that is equal to c squared. So root 120 is equal to c squared, which is equal to c, and that is equal to x centimeters, and that is my final answer. So here's another example where I have a irregular shape and I have to use Pythagoras to find this x over here. So this is obviously an irregularly shaped. And I want to use Pythagoras to find this x over here. So how can I do this if I clearly don't have any right angle triangle here? This is where the action of cutting and splitting comes into form. I can see that this D and this A sort of forms a shape, sort of forms a weird line. So what I can do here is I can actually cut this shape like this. So I can say that this is A, and I can say that this shape is B. We can see that shape A is a square, and we can see that D to A, to let's create our own point such as M, is a right angle triangle, and I can see that my right angle is here as this. So shape A isn't a square, actually it's a rectangle since all sides aren't equal. But anyways, so I have rectangle A and right angle triangle B. Now I don't know any sides on this right triangle B. I don't know any sides. So I have DMA. I don't know any of these sides. Now, I can find this MA by just doing 8 minus this side over here, because this 8 is this side, CD. So wait. So BA, which is 8 centimeters over here, is equal to CD, which is this over here, which is 5, plus MA. So MA is just BA minus CD. So it's just 8 minus 5, which gives me 3. So MA over here is 3. So now that I have one side, how can I find DM? Or like MD, this side over here? I can actually see that since this over here is 4, then this over here is 4. As in a rectangle, if I have A and B, and then I have C and D, in a rectangle, C is equal to D, and A is equal to B. So this 4 over here is going to also be 4 over here. So I have two sides now. So let me reconstruct the triangle here. I have 4, 3, and x. And now is when I can use Pythagoras to find x. So x is just a squared plus b squared equals c squared. And then 4 squared, which is 16, plus 3 squared, which is 9, gives me c squared. So c is equal to the root of 16 plus 9. 16 plus 9 gives me 25. So root 25 is equal to c. Root 25 is equal to 5. And 5 is equal to x. So 5 centimeters is equal to x, and that is my final answer. In questions like these where you have irregular shapes, you need to use critical thinking. You need to construct your own shapes, your own rectangles, your own squares, your own right angle triangles in order to find the length. And what I can recommend in doing these types of questions is to not be scared. So don't be scared of splitting the shape like this and just assume it's wrong, or don't be scared of putting the right angle here and assume it's wrong. You have to be sort of confident in these sort of questions. And yeah, that is going to be the end of this video for Pythagoras. Now, Pythagoras will be used in the future in other videos and in other topics such as trigonometry. You guys will see. I think I'm going to do that next video. But yeah, that's it for the basic laws of Pythagoras. I hope you guys understood this video, and I hope you guys have a good day. Thank you for watching, and goodbye.